Subtopic 3.4 Electromotive force, internal resistance and potential difference.
Objective. At the end of these lessons, students should be able to define EMF and internal resistance R of a battery, state factors that influence internal resistance, describe the relationship between EMF of a battery and potential difference across the battery terminals.
Sources of EMF. Any device that pumps charge is called a source of EMF, like generator, solar cell, or battery. What is EMF or electromotive force? EMF is not a force at all. It is a potential difference across the terminal of battery. So the definition is the energy provided by the source, battery or cell to each unit of charge that flows through the external and internal resistance.
Enough of these charged particles are separated, a potential difference is created. Electromotive force is a potential difference measured in volts.
The symbol for EMF is epsilon, and the unit for EMS is volt or capital V. The circuit diagram for EMF is represented by the two lines. The longer line is the positive terminal, which is higher potential, and the shorter line is negative terminal, which is lower potential. What is terminal voltage? Potential difference across terminal of battery V is defined as the work done in bringing a unit charge from the negative to the positive terminal of the battery through the external resistance only. Potential difference across terminal of battery, also known as terminal voltage. The symbol for the terminal voltage is V, capital V, and unit is volt. Look at the video. Please compare the initial voltage and the final voltage after the current flow.
The electrical potential difference forces current flow when a circuit is attached to the source of EMF.
Why the radio of final voltage is different from the initial voltage? To know this answer, please watch the video until the end. So the terminal voltage, or V, is the output voltage of any device. Like this diagram, VAB, potential across point A to B, actually is the terminal voltage. So it seems like equal to the potential difference across external circuit, across arc. Internal resistance R is defined as the resistance of the chemical inside the battery between the poles. What inside of battery? A typical battery needs three parts to create electricity, which is anode, the negative electrode, cathode, the positive electrode, and also the electrolyte, the medium that provide the ion transport mechanism between the cathode and the anode of a battery. All batteries have some internal resistance at some degree because the elements like electrodes and electrolyte are not 100% conductive. So what factors that influence internal resistance are. Internal resistance R is directly proportional to the distance between the electrodes, inversely to the facing area of the electrode dp in the electrolyte. Inversely proportional to the temperature of electrolyte means that the increase of temperature, the decrease of internal resistance. It is because as the temperature increase, mobility of the ion increase inside the electrolyte, and the internal resistance inversely proportional to the conductivity of electrolyte, means that the internal resistance depends on the nature of electrolyte. So what is the relationship between EMF and terminal voltage? The EMF is the potential difference between the terminal during open circuits, but the terminal voltage is the potential difference between the terminal of battery during closed circuits. Look at this diagram. During open circuits, the current is not flow. The terminal voltage is equal to the EMF, but in the closed circuit means that the current flow, the reading of voltmeter is the terminal voltage is less than EMF. EMF is supply voltage, but the terminal voltage is the effect or output voltage of a device. Both of them are same unit, which is volt, and electromotive force is dependent of resistance in the circuit, current in the circuit, and internal resistance of the cell or battery, but the terminal voltage is depend on the resistance in the circuit, current in the circuit, and internal resistance of the battery. Why does value of potential different? That means that terminal voltage less than electromotive force.
There is typically some amount of resistance in all electrical components and devices. When current flows, the voltage across the terminals of the source of EMF is no longer the unloaded voltage value. There will be a voltage drop inside the device due to the internal resistance of the EMF source. When the circuit was not connected, the battery had an unloaded voltage rating of 1.5 volts. Once the circuit was connected and current started to flow, there was a voltage drop across the internal resistance of the device, and the applied circuit voltage was reduced to 1.3 volts.
So what is the effect of internal resistance to the terminal voltage? Without internal resistance, the reading of voltmeter, which is terminal voltage, is equal to the EMF, but during current flow with the internal resistance, the terminal voltage is less than EMF due to the drop voltage across the internal resistance of the battery. In conclusion, terminal voltage is the potential difference across external and resistance, and EMF is the potential difference across external and internal resistance. Voltage drop across the internal resistance is potential difference across the internal resistance. Which statement is true about EMF? Yes, correct. The answer is A. Which factor affect internal resistance? Yes, correct. The answer is A. That's all. Thank you.